Okay, finally, we're going to do some operations with these vectors, and we're going to use grid paper. Now, grid paper, this may be obvious to you, but grid paper is kind of helpful to use because it helps you keep the direction and the magnitude of the vectors constant, because you could count the squares to figure out how big it's supposed to be. So we're going to be using these two vectors, w and v, for our next operations here. And the first thing they want us to do is to write those vectors in component form. So I think maybe we'll just zoom that out a little bit so we can see it all together. So for vector v in component form, do a little sketching on here. To figure out the x component, I need to know how far right or left I would have to go to get from the tail to the head. So essentially I'm going to kind of draw in a triangle, a right triangle. Maybe I should just use the line tool. There we go. Okay, so I'd have to go that far, and I can count that in just a minute. And then how far up or down I would have to go would be my y component. So I'll draw that one in, and then I can count the squares. All right, so now I'll go back and do my counting. So across this way, that's a length of 3. And direction matters, remember. So this one, because to get from the tail to the head, I had to go to the left, I would put a minus in there. And then for the y component, I'll count the squares again. 1, 2, 3, 4, 5. That's 5. And again, direction matters. So this one, to get from tail to head, I'm going upward, so that would be a positive 5. So my component form for v, I'm going to start with the correct notation there. These arrow edges, they're arrow brackets. And then I'll put my x component first and my y component second. All right, so we'll do the same with w there. This time I'm going to do it without drawing things on the grid up there. I'm just going to look at it and see what I can come up with. So I'm going to start with my arrow brackets. To get from the tail of w to the head of w, I would have to go to the left 2. So that would be a minus 2. And then from the tail to the head, I would have to also go down 2. So that would be minus 2 again. So these are my component forms for each of those. Okay, so now we're going to perform some operations on these things, both algebraically and geometrically. So I'm going to do geometrically first because we've already been doing that. So for my first one, I want to do v plus 2w. So I'm going to come back up to the top here and I'm going to write down what I'm doing. So v plus 2w so that I can see it. So that means I have to start by reproducing the vector v. So I can reproduce it anywhere I want to. So I think I'll start right here. And to reproduce it, I have to go 3 to the left and 5 up. There we go. And then I'll put a head on that because direction matters. So this is my v. Okay, then I have to add to that 2 of the vector w's. So I'm going to do vector w in pink. So for vector w, I have to start at the head of this one, and to recreate vector w, I have to go down 2 and to the left 2. There's one of them. And then I have to do it again because I need 2 of them. So starting on the head of the one I just finished, down 2 and to the left 2. It looks a little bit crooked, but that's just because I'm not perfect. There's another W. Okay, so now remember your resultant vector has to connect the tail of your original one to the head of your final one. So I'm starting at the tail of V, and I'm going to end at the head of the second W. And then the direction matters, so I'm going to go ahead and put in my arrow there. So this one down here is V plus 2W. That's represented geometrically. And once I've done that, I can get rid of all of the extra stuff here. That's all scratch work. All right, so now I've done it geometrically. I did it on the grid because that's the easiest place to do it. And I have it labeled so I know which one that is. But now they want me to do it algebraically. So let's talk about that. Now, truthfully, this one is kind of intuitive with the things that you know so far in your math life there. If I just gave you this information here and I said V is these crazy looking brackets, -3, 5, and W is these crazy looking brackets, -2, 2, and I wanted you to add V plus 2W, and I hadn't told you any of this stuff already, well, you'd probably start off just substituting them in. So you'd say -3, 5, and then you'd say plus, and you say, well, that's 2 times, and then substitute in for W's, -2, -2. And then because you do have some experience with math, you'd probably look at this and say, well, I think what I probably need to do here is multiply this 2 by everything that's after it, because multiplication happens before addition. So that would make that -4, -4. And then probably I would just add together the things that are in the same positions. Ran out of room there, so I'm going to move over here. So I'd start with this bracket here, and then this -3 and this -4 I would just add together. And then this 5 and this -4 I would add together, and that would give me 1. So the component form of the vector v plus 2w would be -7, 1. Now if we take that and go back and look at what we drew, to get from the tail of the resultant vector that we drew to the head of the resultant vector, it looks like we would in fact have to go 7 to the left. So 1, 2, 3, 4, 5, 6, 7, and up 1. So algebraically or geometrically, we end up with the same result. It's kind of a nice thing. Let's go see what else we've got here. Now we need a W minus V. So I'm going to come back up here and I'm going to do W minus V. And I think I was doing my W's in pink, so I'll stay with that. I'm going to write down what I'm doing, just because it's so far down the screen there. So that means to make this one happen, I have to start with vector W. So I'm going to recreate vector W. So I think I'll start it right here. I can start it anywhere I want to. It doesn't matter. The location is unimportant. What is important is direction and length. So there's my vector W. And that's not going to work. Let me try that again. Okay, so let me try that again. I'm going to start vector W right here. Go down and to the left. And then the direction will head on it there. So that's vector W. Okay, then to subtract V, that means I'm adding the opposite of V. So I'm going to start on the head of W, and I'm going to recreate V, but with the head on the other side. So V, remember, was it was to the left 3 and down 5. So if I wanted to do this, I would have to go down 5 and then to the right 3 to make it go opposite direction. Oops. That didn't stay where it was supposed to. Oh, yeah, I can fix it. Okay. All right, so now I'll put the head on that one. And this one is the opposite of V. Okay, so finally, I want to connect the tail of the first one to the head of the last one. And then put in my direction on that one. And this would be my resultant vector, my W minus V. So once again, once I've got that, I want to get rid of all of my scratch work vectors in here so that only the resultant vector remains. Okay, let's go down and see if we can do this algebraically now. Okay, so once again, if I showed you nothing about this and I just put this in front of you and said, here, see if you can figure it out, what you would probably do is start with a substitution. So you'd say, well, V is this crazy looking thing, -2, -2. Then there's a minus sign. And then W is another similar crazy looking thing like that. And so then if I wanted to perform those operations, I would start probably with distributing that minus, because anytime there's a minus before any kind of grouping symbol, it gets distributed. So that would make this plus a +3, -5. And then we would just do positional addition there. So the first position of the first one plus the first position of the second one. So -2 plus 3 would be 1. And then -2 plus -5 would be -7. So my resultant vector on this one in component form would be 1, -7. And then once again, I want to go back and look at the picture that I drew for W minus E and see if that makes sense. From tail to head, it looks like I would have to go 1 to the right and then down 1, 2, 3, 4, 5, 6, 7. So it matches up geometrically or algebraically. All right, now you answer the rest of the questions.